Okay, good afternoon, Year 12 further mathematicians. Just going to do a request from that exercise I said today, which was exercise 11H, question 7, which is on page 316. It's a question about finding areas. We've got a sketch of a curve, and part A requires you to work out the coordinates of A, B, C, and D. In other words, find the x-intercepts and find the y-intercept. So let's do the y-intercept first. That's the easiest one to do. So when y is equal to, when x is equal to 0, replace every single x value with 0. If you type that into your calculator, you'll probably get 3. So D has coordinates 0, 3. Okay, to work out the x-intercepts, that would occur when y is equal to 0. So you've got 3 cos x root sine x plus 1 is equal to 0. Divide by 3, cos x root sine x plus 1 is equal to 0. And now you've got the product of two functions. And the answer is 0, so either cos x is equal to 0 or root sine x plus 1 is equal to 0. If you solved cos x is equal to 0, you would get pi by 2. Actually, based on this sketch, I'm going to consider 3 values: minus pi by 2, pi by 2, and 3 pi by 2. Because this curve would repeat, I just need to make sure I get the correct values. Solving this one, square everything. Make sine x the subject. And when sine is -1, what do we get when sine is -1? I'm going to quickly draw a sketch. So there and there, so that would be minus pi by 2, 3 pi by 2. So based on that, the first negative value is minus pi by 2, so A would have to be minus pi by 2. The smallest positive value is this one, which is pi by 2, so B would have to be pi by 2, 0. And then the next smallest positive x value is 3 pi by 2. So C would be 3 pi by 2, 0. And that would be it for part A. Part B, I'm going to use a substitution to integrate 3 cos x root sine x plus 1 with respect to x. So they've insisted that I use a substitution. With a substitution, you normally focus on the more complicated looking bit and then replace that with a random letter. So if you're going to do that, I would focus on the thing inside the square root and then call that u. And see if this works. With a substitution, you replace every single x with a new letter, which is u. That'll also include the dx. So du by dx is equal to sine x differentiates to cos x, and 1 disappears. If you treat this like a fraction and make dx the subject, dx would be equal to 1 over cos x du. And then you make the substitution. In this case, every single place I see is sine x plus 1, replace it with the letter u. Not going to touch the cos x's because it'd be too complicated to work out what cos x would be. But something, if I pick the right substitution, something should happen anyway. So I is equal to integrate 3 cos x square root of u times 1 over cos x du. And this looks like a good choice because the cos x's disappear. And I have to integrate 3 u to the half du, which is equal to add 1 to the power, divide by the new power, plus c, which would simplify to 2u to the power of 3 over 2 plus c, and they probably want the answer in terms of x, which is 2 sine x plus 1 to the power of 3 over 2 plus c would be my final answer. Okay, now on to part C, where we're asked to show that the regions R1 and R2 of the same area and find this exact value. So back to the start, going to work out here is R1 and R2 using definite integration with the limits, which were minus pi by 2 and pi by 2 and then pi by 2 and 3 pi by 2, and they should be equal to each other. So let's try and do that. So just combining parts A and B effectively. So R1 would be integrating between minus pi by 2 and plus pi by 2. That function, which was 3 cos x square root of sine x plus 1 dx. And that would be what we've got there. 2 sine x plus 1 to the power of 3 over 2. You don't need the plus c because they will cancel. Like that. And then if you substitute that into your calculator, it will probably give it to you as a decimal rather than as a surd, because it looks like we want a square root. So okay, let's do this the long way. So let's show the substitution. So 2 sine pi by 2's plus 1 to the power of 3 over 2, subtract 2 sine minus pi by 2's plus 1 to the power of 3 over 2. Okay, sine pi by 2 is 1, so it'll be 1 plus 1 to the power of 3 over 2. So that would be, that term would be 2 root 2 cubed, which is 2 root 2 times 2, so 4 root 2's. Subtract sine minus pi by 2 is minus 1, plus 1 is 0. 0 to the power of anything is 0, and then 2 times 0 is 0, so subtracting 0. So that would be the area of R1, and then R2 would be integrating between pi by 2 and 3 pi by 2 of that same function, cos x square root of sine x plus 1 dx. So substituting these limits instead, and hopefully you'll get the same value. which is equal to, so sine of 3 pi by 2 is minus 1. Minus 1 plus 1 is 0. 0 to the power of anything is 0, and then times by 2 is still 0. Subtract sine pi by 2 is 1, plus 1 is 2. 2 to the power of 3 over 2 is square root, which is root 2. Cube that, which is 2 root 2. Then times by 2, which is 4 root 2, which is minus 4 root 2, which kind of does make sense because remember, integration gives you directed area. So the area above is plus 4 root 2. The area below is minus 4 root 2. Therefore, the areas are equal. So, areas equal as required. And that would be it.